Hi, welcome to Parametric House. In this PH Academy video, I want to show you how you can use the array morph cluster we have developed. We're also going to learn how the algorithm works. So first, what I want to show you is the first input is the geometry. So assume that we make this in Rhino, which is really easy to make, just two boxes, and we can give it to this input. The next input is the base curve. So as you can see here, we just made a simple line at the bottom. This is going to be the backbone of the morphing of the geometry. So that is going to be the base curve. Then we have the target curve. So we can just simply draw a curve in Rhino and give it to the input. As you can see here, by changing the curve, this is going to update. So this is also going to get out the mesh and the NURBS. For the mesh and NURBS, we can say if we want a quad mesh or not. So here you can see if I bake the mesh, I can have them as a mesh in Rhino, which I can use it in my project if I want mesh. And if I want a NURBS, we can just put this to false and use the NURBS part. This is going to be the NURBS. Another thing I want to explain here is the rebuild target. So this can make the morphing a uniform output. So just increasing that is going to give you more precision. This is not really that important, but decreasing it, as you can see here, the curve is going to be made with less control points. The most important part is the count. So as you can see here, I can say that I want 3 of this pattern on the curve. We can, for example, just use the Control Shift and bring this surface a little bit up and then just set it again. So you can see that the height is going to increase. That's also important. Okay, for example, for the base geometry, you can see that I have made this in Rhino and given this to the base geometry. The base curve is going to be a line here, and the target curve is a simple arc. So if I flip the base, you can see that the direction of the top part is going to change. Also flipping the target, which is going to be the target curve, is going to give you similar results. So you can always flip the target curve or base curve with these inputs, which I'm going to explain about the algorithm later. Another thing is the quad mesh. So if I just say quad, I can have that in Rhino as a quad mesh, as you can see here. And if I want the B-rep, I can just say the NURBS. So this is also going to be the NURBS, which I can produce in Rhino. Okay, before we go forward, I want to show you how you can make a sine wave in Grasshopper and give this to the cluster. So in the algorithm, we can control how many of these parts we can produce with the cluster. So I can say 1, 2, 3, and so on. Again, I can say if I want a quad mesh or not and just bake it. And here you can see we can make a sine wave. Okay, let's talk about the target curve, which is going to be the sine wave. I'm going to clear this so we can write it from scratch. To make a sine curve, you can simply produce a series of points. I'm going to go to the vector and use a construct point. What we can do here is to make a range and define a domain. So for example, if I say like 12 with 2 decimals and give this to the range and give it to the x, you can see that we can produce a series of points between 0 and 15 by just defining a range. Let me go to the full name so you can see the inputs easier and understand it. Another thing we have here is a step. So just increasing the step is going to give you more details. So I can just increase or decrease the details if I want to. And then we have to make a sine wave in the y direction. So we have to make a sine. To do that, the easiest way you can do that is going to the math and trigonometry. I can use the sine and then give that to the y. You can see that we can make a sine wave easily by just controlling that. Because we want to control the sine wave, instead of giving it a number, I'm going to type pi, pi. You can find it in the math utility pi. And if I give it here, you can see that the factor 1 is just like the top part of the sine wave. So I can say I want a 1 or maybe 10. That is going to control the number of the sine wave, so I can increase it to 2, 3, 4, and remember, increasing the resolution is going to give you better results. So now we can just play around and produce this sine wave curve. The last step is to just connect it with a curve. So I'm going to go to curve and say interpolation, turn off the points, and we will have the sine wave here. Now we can give this curve to the target curve and just go to quad mesh off, and you can see how easy it is to control how many number you have here. The problem here is that when we make like one sine, we have number of division of count of 10 here. So what we have to do here is simply give the same number we had here to the count. And now you can see it's just like one division for this. When we put it to 2, it's going to divide the complete sine curve into 2 of this module, and so on and so forth. Okay, so that is also really helpful if you want to make a sine wave. PH Academy users can download the cluster, the algorithm, and the sine wave that I've explained just now. Okay, thanks for watching. If you want to download this array morph cluster and also learn the algorithm and how it works, you can check out the link below, which is for our exclusive users in the PH Academy website. And see you next time. Bye.